Welcome to Lecture 8, Numeric Conversions. This lecture is all about casting of numeric types. Basically, what it means is when we have different numeric data types, like integers and doubles, they hold different types of data. For example, an integer only holds whole numbers, whereas doubles can hold whole numbers and decimal numbers. So when we're trying to store numbers and convert between integers and doubles, we can run into some problems, and some converting happens for us that we may not even know about. So the first type of converting or casting is implicit casts. Implicit casts. Basically, implicit casts are conversions that are happening automatically without us even knowing. For example, if I have int x equals 5, and then I created double y equals x. This is a conversion. I'm converting my integer into a double, and I didn't even know was happening. This is implicitly. It's doing it automatically because, and the reason why it can do it automatically is because the entirety of an integer can always fit inside of a double. And that's because a double, like I said, can hold a whole number or a number with a decimal, whereas an integer can only hold a whole number. So a double can hold everything an integer can have. That's why when we convert from an integer into a double, the conversion is very simple. However, if we try to go the other way, that's where we run into some problems. So let's create two new variables. Double my double equals 5.5, and then let's say int my int equals my double. Notice now that we're going to get an error. And the reason why we're getting an error is because we cannot convert a double to an integer. Notice how when I put my mouse over it, it says cannot implicitly convert type double to int. It's saying that you need to explicitly convert it. And then it says, are you missing a cast? So basically, what is casting? Casting is the force of converting something. You're forcing it to convert it. But no matter what, in the conversion, something needs to leave. Because a double can hold a 0.5, an integer cannot. So even if I force this double to become an integer by forcing it using a cast, I'm still going to lose something because an integer, no matter what, cannot hold that 0.5. So what happens is it doesn't round it. It doesn't do anything like that. It just drops the 0.5. It truncates it, throws it away. The 0.5 goes away so that my int is only left with 5. So the way that we say force it, basically the error is there saying, it's giving us a warning saying you're going to lose some data with this conversion. But if you're okay with that, then tell me you're okay with it. And the way you tell me is by casting. So the way we perform a cast is we use parentheses before the variable, and inside the parentheses you put what you're trying to convert to. So I'm trying to convert the double into an integer. So I'm saying force this double into an integer. That's what that cast says. And it's saying that I know that I'm going to lose some data, but I still want you to convert it no matter what. So my double becomes an integer, and now that's dumped into my double. If I try to print my int to the console, we'll see that we'll see a 5 instead of that 5.5. So that 0.5 gets dropped off in the conversion because I'm converting to an integer which it can't hold a 0.5. So we're only left with the whole number of 5. So that is a basic explicit cast. You're just telling the computer that you know that it's okay that you're going to lose some data. It's okay that I lost that 0.5. The cast basically says squeeze it into that small integer. Do whatever you have to do to make this number, this double, fit into that integer. So it's going to squeeze as hard as it can, and the 0.5 is going to basically get cut off, and then that will be that whatever's left over gets stored into the integer. So that's an explicit cast. Now remember, this is an implicit cast because it's converting from x to y, which is an int to a double, but we are not losing any data. That's why we don't have to try to cast it. We're not losing anything because a huge integer can always fit into a double no matter what, but it cannot go the other way. A double cannot always fit into an integer. So that's it for this lecture. I just wanted to briefly show you about how we can convert numbers using casting.